All right, guys, we're now going to focus on the regression part of the lecture. Now, it says here, and we go more detailed in Stats 250 when it comes to regression, because it's very important and it's even more important for high levels of statistics. Statisticians have traditionally agreed that when we conclude that two data sets have a relationship, we can be satisfied with the conclusion that there is either a 95% or a 99% chance that we are correct. And we call this our percentage of confidence. This corresponds to a 5% or 1% chance of being wrong. If you are 95% correct, you have a 5% chance of being wrong. And we call this right here our probability of type 1 error. But once again, those are Stats 250 terms. These percentages are called significant levels. If a relationship is significant, we can find what is called a regression line, or the line of best fit. Basically, when the relationship between two variables is statistically significant, you can use the information that you obtained for a sample or from a sample and use it to predict the trend when applying it to a population. Remember the purpose of statistics. We want to take data that we collect from a sample, and if it is statistically significant, we want to apply that to a population that is under study. In this class, we're not going to go over significance levels. No, it does mention it in the textbook, but I'm not going to bring it up here. We're just going to assume that the relationships that we have conducted are going to be significant. The regression line is the data line of best fit. And once again, we're going to use the regression line to predict our data values, as you're going to see in this question. The purpose of a regression line is to enable the researcher to see a trend and make predictions on the basis of the data. In statistics, the equation of the regression line is written as y prime equals to a plus bx. Now, don't think of y prime in terms of a derivative. This means predicted y value. Predicted y value. And A is the predicted Y-intercept. B is the slope of the regression line. If you notice, this right here is basically a linear equation. It is similar to the equation of y equals to mx plus b. But in this case, these means different. A and B are like the slope and the intercept. They're the same kind of formula, except just to a different branch of mathematics. Okay, enough talking. Now, this is how you find the equation of the regression line if the relationship between your two variables are statistically significant. To compute the predicted Y-intercept, this is the formula that we're going to use. And to compute the slope of the regression line, we're going to use this formula. And it's good because we already found these values here. If you look here, we found these values. Therefore, I do not have to create the table again. I can just look at the information that I got from computing my correlation coefficient, substitute it into these two equations, and then I'm going to use it to predict the information that is right here, which is number 3. Find the equation of the regression line for question 1. Predict the final grade for 2 absences and for 15 absences. Okay, let's go ahead and do that. Now, let's find the predicted Y-intercept. A is equal to the sum of Y, and the sum of Y, once again, was 495. And if you need to, you can look at these values again. You can screenshot it, write it down, and we can use it to plug it in. I'm just taking these values right here. So that's 495, and it's multiplied by 579, minus the sum of x, which was 57. And that's times the sum of x times y, which was 3,568. Let's double check that to make sure I'm correct. Yes, I am. Now, that is going to be divided by n, which is 7, times the sum of the square for x, which was, once again, 579, minus the sum of x. The sum of x is 57, and we're squaring this. Now, my denominator right here, we did this in the last question. Let me scroll back up. We found our denominator in this bracket right here, and it was equal to 804. That is good, because now I can cut out some math. I know now, even if I do compute this again, it's going to be 804. Let's just multiply the tops. Let's clear that. 495 times 579 minus 57 times 3568. We just did the correct. 83,229. And we can divide that by 804. And let's take three numbers after the decimal. That is approximately 103.519. That is my predicted y-intercept. Let's find the slope now of our regression line. So n is 7 because we had 7 students. So 7 times the sum of x times y, that is going to be 3568, minus the sum of x, which was 57, times the sum of y, which is 495. And if you notice, if you look right here, these values are the same. This part is the same as the numerator of the correlation coefficient. And I know already that my numerator, when I did the mathematics, was negative 3,239. So we can just make that connection. Furthermore, look at your denominator. The denominators between the predicted y-intercept and the slope are the same. And my denominator was 804 for my predicted y-intercept. So I know for my slope, my denominator will be 804. When I do the math for the numerator, that's going to equal to negative 3,239 divided by 804. Let's go ahead and do that. Let's take three numbers after the decimal. That is going to be equal to negative 4.029. That is going to be the slope of my regression lines. Let me double check to make sure I have the right numerator. Yes, I do. 3,239. Therefore, the equation of my regression line is going to be my predicted y value equals to A, which is my predicted y-intercept. That is going to be 103.519 minus my slope. In this case, it was supposed to be plus, but because the slope is negative, I'm going to put minus 4.029x. That is the equation of my regression line. Okay, before I continue, in the last video, I promised to show you guys how to do it in the calculator. Now, I'm going to keep my word, and I'm going to show you now how to do it in the calculator. So let's go back up to this table right here, right? What I want you guys to do is I want you guys to go to stats on your graphing calculator. Now, in list 1, put all your X values. So 6, 2, 15, 15, delete that, 9, 12, 5, and 8. Now, in your second list, put in all the Y values. 80, 99, 43, 60, 58, 77, 78. Okay. After you do that, I want you guys to go back to stats. When you go back to stats, I want you guys to go to calc, right? And if you notice, these are 2 variables. So I want you guys can go to 2 variable stats. Click on that. Matter of fact, let's actually start from the beginning. Stats. Let's do 2 variable statistics. Now, usually you have to put in L1 and L2. So second, click on 1 for L1, put your comma in. Second, click on 2 for L2, close it up, hit enter. And now, after you hit enter, remember, you need to find certain things when it comes to this. And if you notice, you get all the values that you may need. So I want to see why they have 436 for this right here. Let me check something out in my data. Make sure I put everything in correctly. 9. This right here is supposed to be the number 12. I don't know why 12 didn't go in. So let's put 12 in there, hit enter. Let's redo it. So let me just quit this for a minute. Clear this. So that's going to be stats, 2 variable statistics. Once again, although it displays it right here, you should put L1, comma, L2. Hit enter. And then see for your regression equation, you have everything that you need. Look here, the sum of X, 57. The sum of the square for X, 579. N is 7. We need N for the equation. The sum of Y, 495. The sum of the square for Y, that is going to be right here. We got 37,027. And then the sum of X times Y, 3568. So we can do that in the calculator. And give you some other statistics that you may not need. Well, you don't need for this class right now. But yeah, we can focus on that. Now, if you want to go a step further, if you want to find the correlation coefficient and you want to find the equation you need for the regression line, you're going to go here, go to stats, make sure you're in the calc. You're going to hit what is called linear regression, which is right here. Click on that. Usually you got to put in L1 and L2. You should always do that. Hit enter. Now look what it gives you. It gives us the A and the B. However, one thing about this is it is reversed. I don't like that. I don't like it. But if you remember what happened, and the reason why it is reversed is because the variables in this equation is the opposite of the variables that is used for the equation of the regression line. So in this case, it says the B is going to be the intercept, and it says the A is the slope. If you want to change that, you can reorder the list, but keep that in mind. But even more, it gives us R, which is the correlation coefficient. And the correlation coefficient was, once again, when we rounded the 3 numbers after the decimal, negative 0.960. Look here, this is round three numbers up to the decimal, negative 0.960. All right, guys, let's continue. Because it says here, predict the final grade for 2 absences and 15 absences. So let's clear this since we don't need it no more. Okay, to find that, we're just going to input what we need to input into the equation of our regression line. So to find 2 absences, we're going to say that x is equal to 2. Plug 2 into the equation of the regression line. My predicted y value will equal to 103.519 minus 4.029 times 2. Let's do that in the calculator. 519 minus 4.029 times 2. Let's round to the closest whole number. Now we take one number after the decimal. That should be fine. Y is approximately 95.5. So predicting 2 absences in this case will have a final grade of 95.5. Once again, when we predict 2 absences, the final grade will be 95.5. And let's predict for 15 absences. So that means x equals 15. So y prime equals to 103.519 minus 4.029 times 15. What I'm going to do is I'm going to kind of copy and paste. Okay, that didn't work. So 103.519 minus 4.029 times 15. Approximately 43.1 as the final grade. If we check out the actual values, remember, these are my predicted values, the actual values for 2 absences. A student in this case who had 2 absences had a final grade of 99. When we predicted that was 95.5. So remember, it is a prediction. It is not a guarantee, but that is a close prediction. The prediction is even stronger when it comes to 15 absences, because when a student has 15 absences, in this case, the actual value was 43 for their final grade. And when we did our prediction, we got 43.1. So we can also conclude that the equation of this regression line is a good predictor. All right, guys, that is it for this video. Hope you enjoyed it. Hope it made sense. I'll see you soon. Take care.